And next up, we have Alexey Zimarev. And Alexey is the CEO of Ubiquitous, developer advocate for Event Store, chief architect in Abex, and also the author of Hands-on Domain-Driven Design with .NET Core. And his particular interests are in event-driven architectures, domain-driven design, distributed systems, and event sourcing. Interests that led him to create Eventuous, which is also the topic of today's talk. We're all looking forward to learn what Eventuous has to offer. Take it away, Alexey.
Thank you for the introduction. It's been a lot said about me, but let's move to the topic. Hello, everyone. I want to talk about Eventuous, and that's the first time it's going to happen in public because it's been undercover for some time, although I managed to sneak it into some production systems during last half a year. And I think it's been a success, so I believe that's time for me to share it with more people than it used to be shared. So what was the motivation for me to create Eventuous, and what is it about? Some of you who have been here last time, I don't remember, some months ago, maybe you remember me talking about event sourcing. And in particular, I was pointing out some of the things, some of the issues that people create for themselves when building event source systems. These issues are not infrequent. And Greg, a colleague of mine from Event Store, he was doing the talk, how Event Store works. But he also did a great talk in one of the conferences in November. And you find the recording. You can find the recording, and don't watch the comments and the Q&A. The talk itself was great, but Q&A wasn't. The talk is called "Why Event Source Systems Fail." And what I learned that event source systems usually fail because people don't have enough they understand it in theory, but when it comes to practice, they get lost. And I explained, or I went through during my last talk, I went through a bunch of under patterns and the common mistakes that people make. But okay, giving a talk is one thing, and I can say this is not the right thing to do, and this is how we should be doing it. But this is also just a talk, it's a theory. So it doesn't give you any practical instruments to implement your event source systems. Maybe if you're building the first time, maybe you started building something on your own and try to build all these Lego blocks, as we can call them, and it doesn't go that well, and you bump into issues time after time. So that motivated, and I've seen it in my practice and working in event stores, developer advocate, I see that in our customers' environments as well. So one way to solve it is, of course, for me to say, I'm an event sourcing consultant, so pay me big bucks, and here we go. I will tell you how to build it, and I will show you the code that is I have as a precious secret somewhere in my private GitHub repositories. But I chose another way, and I started Eventuous, which is the event sourcing, we can call it a framework, but it's actually a set of libraries that building blocks that, in my humble opinion, could help people to bootstrap their event source systems and help them to build it and avoid those mistakes that I talked about. That's how Eventuous was born. I started it in, I think in May or late April this year. And it's under continuous growth and development and more things. Like the roadmap of Eventuous is pretty substantial. So it's by far not complete. But I think it's now the stage where it can be actually used. We use it in production in some companies, and that gives us certain degree of confidence that it actually works. And I can tell you about the scale of production system that we're using it in a moment after we look through some code. So I don't have any slides, so forgive me about that. But I have a bunch of code, so bear with me. Let me share my screen and I can show how it looks. So that's the framework itself. Let me just close all the tabs I have. You see, I have it almost always open on my screen, and you can count number of projects here, which is a lot, but don't be scared. A bunch of them are test projects. So it has four core projects, 2 brand new projects for diagnostics, where I want really to talk about it more. At the core of Eventuous, in terms of where the events are stored, is EventStoreDB. Naturally, not only because I work for EventStore, but because I use EventStoreDB for many years. It's been 6 years by now since I started using it. And one of the foundation principles of Eventuous, at least for me, like I build it for things I use, right? And since I'm using RabbitMQ and I'm using Google Cloud, I built some packages to support Google PubSub and RabbitMQ for the messaging part of Eventuous. Surprisingly, when it comes to event sourcing system, the messaging part comes along and kind of naturally, almost automatically when we move to the integration space. But I will talk about it in a moment. So, bunch of things. A lot of them are new. And if we look at, where is it? Yeah. If we look at the documentation website, it doesn't look so really bad, but it's by far not complete. So I started to compose this documentation with the aim to explain some concepts as well. So it's not purely documentation, it's also quite a lot of conceptual information about the persistence, real-time subscriptions and stuff like that, what the domain looks like, and what the domain events are, how, yeah, you see, that's not that much. So what stores look like and stuff like that, how to work with serialization, what is application layer, and so on. I also have this controversial article. It's called The Right Way. Of course, that's how I think is the right way. And I have this big thing against using event bus and event source systems. If you, well, my colleague Oscar, who is probably listening now, did a talk at Event Sourcing Live not long ago. It hasn't been published yet, but when it gets published, please watch it. He talks about the worst event source system ever, and in the source of every worst event source system is actually the event bus. This site will be redesigned. I mean, it's already there. It's just not published yet, with a lot more information about all the components I have in the library. But what I want to show is how it actually looks to work with Eventuous. So another foundation principle, like the principle of building things that I use, maybe it's not that strong, because I could build things that also interest me. For example, I plan to build some integration with serverless in AWS, although I'm not using it AWS hands-on, but maybe I will. I just have interest in serverless space. But of course, I welcome contributions. So if you use something else, please provide your code if you want. But another principle, and this is a very strong one, is basically try not to fight the platform you're working with. And the Eventuous, we have 2 projects. One is Eventuous.net, and another one, Eventuous, is Dart, which is created and supported by friends from DiscoSS. They build software for rescue operations, and they're a nonprofit. So, but we're not really like the same, right? So they use some of the ideas and they use some of the principles, but they are completely independent. The .NET version is the .NET version. So it doesn't fight the .NET framework, and it uses the most of it. At least I believed that's what it does. So that's why I think it's really, the aim is that for the .NET developer who is hands-on with the latest developments in the .NET space, it should be really interesting and exciting to start using Eventuous. Let's go from bottom up. So not look at, this is the normal application startup file from .NET 6. But if you look at the domain model, I hid some files, so we'll start showing them up in a moment. So every event source, well, not every event source system, but I would prefer if every event source system starts with a domain model. And Eventuous core, the very first project that's called Eventuous without any suffix, is implementing some of the building blocks for creating a domain model. For those who ever encountered to, browse my book or even read my book, you probably can find quite a lot of resemblance between the code in the book and the code in Eventuous, but it's significantly improved. So this is what's the foundation block, right? I'm using DDD terminology here. You can blame me for that, or you can praise me for that. It's up to you. The terminology might change in time if I get convinced that it's not a good one. But for now, it's like this. So the aggregate is the transactional consistency boundaries. For those of you who are familiar with DDD, you recognize it. So I decided the main thing in, the aggregate implementation in Eventuous has several flavors. I'm only going to show you one that I use the most. And this one separates the aggregate state from the aggregate itself. So the logic is separate from the state. I did it for the purpose that the state might be, you might have a requirement to persist the state separately, like you're doing snapshots or you're exposing the state through the API and stuff like that. And that basically creates a requirement that the state needs to be serialized and deserialized. And when it is kind of mixed together with domain logic, it doesn't look good. But if you look at the aggregate object itself, or its class, right, it just has the logic. And we can go through it in a short time. And I have the simple domain. Let's say we book in some rooms in some hotels. Well, it's actually one hotel only because it doesn't have a hotel ID. So we have a very simple ubiquitous language here. We're booking the room, we record some payments, and we mark the booking paid in full if necessary. So the aggregate itself, what it does, it basically is a recorder of events. Every time you emit an event, it will be by using the apply function. I don't like the word emit because in this case, you're not emitting it anywhere. You're applying it in order to change the aggregate state. So it represents a state mutation. As we all kind of agree, let's assume we do. The event sourcing is the way to persist state as a series of events. So I'm not emitting anything. It doesn't go anywhere. I'm just applying it locally to my aggregate state so it gets to the next, the state mutates and it will be the next version of the state. So let me just expose some of the events. And for that, I just need to bring this back. Events, I prefer to represent them as records. Records are immutable, great improvement in C#9. I haven't tried record structs from C#10. They were just implemented in the latest preview, so bear with me, I haven't tried them. The main thing here is that events need to be serializable and deserializable unconditionally. So that's why they consist of primitive types, value types on their own. It also helps with that impotency, because if you start bringing complex types in there, which you can, records do not support deep cloning. When you create a copy of a record by assigning the record value to another variable, it will be a shallow copy. So you only get the first level. All the deep things will be kind of put as a reference. So it's not fully idempotent, unfortunately, but that's how it is. So that's why my events are pretty flat. And sometimes I use complex types there to represent more kind of things, like if you have a list of identical objects, you would rather not use it up. So when this is done, it becomes pretty easy to see that my events are being applied, and I produce them, and so on and so on. I don't have any support for versioning just yet. I think it's responsibility of developer but I might change my mind. The aggregates kind of concept implements, well, it doesn't implement, it provides some of the helpers, like you can call this function ensure doesn't exist if you know something shouldn't happen when there is no entity in the store, right? So it's brand new. So I don't want to debug it twice, so I will say I want to ensure that it doesn't exist. And the other way around, you can call ensure exists. The apply, what it will do, it will mutate the state. Basically, the state is also immutable. It's also a record, and we can have a look at it now. Let me remove the whole thing. The state is a record. It means that it is immutable. So every state mutation produces a version of the state. What it allows us to do is to look at a previous and a new version of the state and compare them. It has some value because you might have invariance of state transitions. So like in certain state transition is not allowed, and you can control it by comparing the previous state and a new state. So the apply function, although I use it without the return type, it actually returns previous and in the current state, which might be useful. I've seen these use cases, and those who read my book have seen these things with in the latest chapter, in the last chapter 13, where I use this to control if the state mutation is actually correct, or it could happen, right? But here I don't use it really. And it adds the event to the collection of events that are produced by aggregate, because in a single transaction there could be multiple events produced, not only one. So you can execute several operations at once, and then persist all of them at once when the transaction completes or commits. So the booking state in this case is the record, which derives from aggregate state. There is not much logic in aggregate state as such. It only has the ID, which is here is it represents generic type. The ID is a record as well, which derives from aggregate ID. It's very simple. Aggregate ID just checks if the value is not empty. So, but it's a value object, and I find records pretty useful for value objects because of immutability and equality and stuff like that. So. One thing that the state needs to do, it needs to know how to mutate when the event comes, right? When you call the apply method, there is a when function under the hood that the aggregate calls on its state in order to transition the state to the next version. And there are two ways of doing it, because I don't like to enforce things on people. So you can also just say, I want to override the one function, and you can use good old this with or switch and then event switch events. Jesus, I don't remember how to syntax switch. Yeah, here we go. And you can say, for example, room booked. And then you can mutate the state, right? Usually you would say this with something. This is one way of doing it. Some people say, I heard a lot of complaints about it, and say, I want to make things kind of separated, so I introduced this thing. So you can register event handlers that transition state from one place to another, and they all must be static, because these are pure functions. They don't rely on the state of the this object. Actually, they receive a state and they produce a new one, which is very neat. And then you can clearly see if you have an issue, because unless the function is actually pure, something is wrong. So in this case, this all state mutations are pretty easy. I use a bunch of other objects here. And everything looks fine. So, and don't pay attention to this red line as bug and writer, which is having issues with records that are coming from NuGet package. So it's not my issue. It actually compiles. So this is how the domain model would look like, right? So there are no more things that I use in the domain model itself. So the domain model has only one dependency on the Eventuous package itself, and that's it. So it's pretty clean, and it's not pure, because in this case I use asynchronous domain services. Is room available is a function which is asynchronous, not necessarily, but you see I use validtask here, but it might be. Some people are against it. I'm not going to discuss it today, so it's another story. Let's move to how it's actually being used, right? And here I have quite a lot of things. So let's start with yep. Let me see if I can. I thought I can just do this, but I can't for some reason. I can try this. I just know that it sometimes looks really weird, like this. But let's see if it helps. So in here I have, let's start with commands and command service. So how the application actually works from the outside, how do you talk to it, right? Remove this. When you talk to the application, I introduce the application layer, because me and my colleagues who I worked with on the event source systems for a while, we believe that the domain model is in the center of things. You might call it ONA architecture, which I don't really like, but more like port and adapters, where the domain model is in the center and it's being called from the outside. But like the last thing I really want to do is to provide access through some sort of API to my domain model directly. Not only because like the API would then need to fetch aggregates from the store and persist them back and stuff like that, which is not a good idea. But also because the application layer might have additional logic, which is not domain logic, but it kind of lives on the outside. That's why I find the application layer particularly useful. And in this case, I have this separation between query service and domain and command services. Command services focused on executing commands only. There is a base class for that, application service. There are a few implementation or abstract classes with different generic parameters. This one is the full one, which uses the aggregate type, state, and the ID. So what does it give you? It basically allows you to create very nice command handlers and forget about all the wiring. You can see that the command service accepts the aggregate store abstraction as an argument, and it also has a dependency on the domain service, which is natural because it's used in the model. But you don't need to load and store events and all that stuff, because it's a repetitive pattern. If you have a new instance of the aggregate, you don't need to load anything. You just execute a command, and then you get events back. and then you persist them, at least try to persist them. And if it gets a conflict with ID, then you get an exception back. If it's an existing aggregate, you need to load all the events, reconstruct aggregate state, execute a command, and then persist new events if they come. It's all tedious and repeatable, repeated work, which I think that's the first thing people usually abstract out, and that's what Eventuous does for you. You can register command handlers here. Basically, this is a command handler. It could be a function in the zone. It could be just inline, lambda, whatever else. In my case, it's pretty easy. So I have two versions here. Bookroom, naturally, it's a new booking, and it's on new. And this one existing, and it has async prefix because I use asynchronous domain service. And this one is a synchronous one because it doesn't use any asynchronous calls. So it just executes the command. But all the things that loading the aggregate from the store, reconstructing it, and putting it back after the command is executed is done by the application service. You can see the difference between on new and on existing, that on new doesn't have the first function that on existing has. Because this one needs an ID. It will need an ID to load the aggregate stream events from the stream and reconstruct the aggregate state. And on new, naturally, doesn't have anything. At least you would like to think so. That's why it doesn't need any ID upfront. It will need it when it persists, but will use one from the state. So commands are also records, so it's not really important. Let me fix the namespace. I haven't paid attention to it. That all looks good. Let's see how it's called from the API. So let's just remove all of that, embedded resource, remove, and get it back. So API, command API. So why is it not happy? Oh yeah, because I changed the namespace just now. Remove this one. So the API looks incredibly simple. Because I receive a command straight from the client who calls the API as is. I just pass it over to the application service. You can very easily attach the what people call validation layer to the API and validate commands before they come here using something like fluid validation. This is something we call like pre-validation. You can validate something on the client side. You can validate something on the API validation side, but please do not put validation rules, complex validation rules in something like fluent validation. That's not how it's supposed to work, right? This is your application logic or domain model logic. It should be there. And by doing so, this layer stays clean. And you can see that's easily replaceable with any API source. For example, you can easily build a gRPC API on top of that, and maybe messaging API, whatever else. As soon as it just produces the same command that it can pass straight over to the application service. You may think that I like to put the user identity information to the command before it's sent to the application server. That's fine. That's exactly what you should be doing here. Because there you have the authorization context, you have user information, stuff like that. You can pass it over. That's okay, but no more. It's so simple and straightforward and one-liners for all the command handlers in the API layer that I think I should start generating them. And who thinks it's a good idea, please go to my issues in GitHub and vote for it. So, but I think it might be a bit easier for people to deal with because that's something you always do, right? You create a command, you handle it in app service, then you need to go here and create 3 lines of code saying this is the post, this is the route, and this is what I need to do. So I'm trying to remove this tedious and boring work as much as I can. So right now it actually should work, but again, so how all these things are wired. And this foundation principle of Eventuous, which I talked about, I don't want to fight the framework, right? I think it's stupid because like it gives me something like decent DI container. Okay, let me use the DI container. That's what I've done here. Now this is a pretty straightforward, simple application. I just add Serialog because I like it a bit more. And then we come to registrations. And I have this thing is called add Eventuous, which is not in a library, it's just a file in this project. Let me just recover it back. And here it comes. This is add Eventuous. And I think it should be called now. And let's just remove this one for a sec. So everything can be registered, and it's a bit, it's not as simple as it looks. This call, of course, comes from Event Store client itself. Our application service has a trick, and I will talk about it later. And the same goes for that Event Store. Aggregate Store is straightforward to the point that I don't think this line needs to exist. I think it needs to be kind of create a helper for it as well, because you always need it, unless you just use subscriptions and producers, which I talk about in a moment. These are the main services that will be injected to the application service. That's why I need to register them. For the rest, that's all I need to do, right? So, and here the wiring is complete. Everything else is done by Eventuous itself. And I believe that if I just run it now, yes, that's not this one. And now I need to quit the presentation mode. The font will be smaller, but not much. And I think I should be able to run it. Yeah. Okay, so it opens Swagger, but I have it on my screen somewhere. Oh, it doesn't, but I can open it. Okay, Swagger. Here we go. We have the API, and it has queries, but we can look at it later. This is the first command that I have in the application service. Without it, nothing happens, because everything else, like recording payment, happens on existing aggregate already. So let me just execute it. I will put some values here, guest ID 34, room ID, whatever. Let's book it for 2 nights and put the price of 100 euros. It's a cheap hotel. Let's try it out. See, it will crash. See, unsupported currency string. This is where domain services help. I have, or domain model helps. You see, I don't have any validation for that, but I do have a money class that has a supported currencies list, and it says unless these are 3 currencies that support, this value object cannot be constructed, so it just doesn't work. Let me put it to euro. I need to introduce Swedish kroner, by the way. Okay, here we go. Interesting thing. It's expected to happen, although I didn't expect to happen now, but nevertheless. So it says the scriptic error. Type room booked is not registered in a type map. So what room booked is an event, right? It's right here. And what happens is that I'm trying to persist this event, and I need to put something in my storage that will indicate what type of event it is, so I can deserialize it back. One of the things I mentioned in my talk, like earlier this year, that people map event because it needs to be deserialized, right? So when you load it, how do you know what type it is? If you just say, I'm very happy with my domain model forever, and nobody else except .NET people will ever read events from that place, I will just put my full qualified class name as event type and leave happily after. I made this mistake. I will never do it again. The issue with that is that you get coupled to bloody namespace and assembly name of your domain model as it stands today. As soon as you rename anything, it will stop deserializing because it just couldn't find a type. So that's why Eventuous has a type map, which is the concept that me and my friend Sergio and others use quite a lot. And I made some improvements for that. At least I tend to believe so. I don't know if it's right. So the type map is it's not exactly a static object. There is an instance behind it, so it can be you can use different type mappers, but usually in application scope you use only one. And you just say, I want to map this class or record in this case, which is a class anyway, to this name. So I want to persist this string as event type in my store, which makes you completely isolated. Like you decouple your event types that you persist from event types that actually exist in your domain model, because they can change, the namespace can change, whatever else. You maybe made a typo in the class name, so you don't want to be coupled to that. So this is one way of doing it, and actually works, but there is a better way of doing it, at least I think so. So what people start to ask me about is that, how do I know if I mapped all my events? Because it happens on the runtime. You see that application starts and you have no indication that something is wrong. One guy asked me to write a Rosen analyzer. I'm not ready for that. If someone knows how to write extensive Rosen analyzers, please reach out. I know how to do it now, because in here, for example, I have in the state, I have events handlers, right, which are explicitly registered. So I can theoretically go and scan all the things in this domain assembly for instances or classes that implement the state or records. And I can look in this dictionary, which is constructed behind the scenes, and to see which events the state handles. And then I can kind of guess if something is not registered. That's probably a good idea. I think I have it in plans. But the easiest way I found out is basically to use, again, attributes, right? So type name, and I can say run books. And don't forget a version. And this one is the payment recorded. So for this to work, of course, I couldn't apply J because it has a hot reload of .NET, which is very nice, but it doesn't work because the startup has already been executed and it needs to happen beforehand. So, and this one is booking fully paid. I need to type it as well, map it. Oh, I can say fully paid. See, I can do whatever I want. I can specify a different name. But here, I have this function that I used to call it from here, right? I don't want to do it anymore. So I can just say, go away. And in there, I would say type map, register known event types, and then it needs an assembly. So because not necessarily this domain assembly has been loaded yet when I call it. And I can say room booked .assembly, right? It will scan the assembly for all the types that it has this attribute and register the types. But .NET 5, .NET 6, we have a bit even better way to do it. We can say I want to have a domain module which has this. What is it now? Oh, I need to stop it, so it keeps complaining. So, and I can say initialize module initializer, and it needs to be whatever void. I don't remember the syntax exactly. So declaration type. Yeah. So map events or initialize model. Must be in order to remember message. I have no idea what it means. Nevertheless, I have done it before, and I think I had to remove it because Eventuous supports the .NET Core 3.1, so it doesn't work everywhere. Model initializer can replace this because even in that case, you don't even need to specify the assembly. You just need to put it there and you forget about it. So because it's pretty new, I'm not familiar with that as like I'd like to be, and I also don't write model initializers every day. So you usually write it, forget how it's done, and next time you need to Google it. So this now should work. So let's try that. Execute, and it's done. So what happens here is that all these things happen for us And we can now look at the, this is the event store DB UI, if you don't know it, so please have a look. And it has all the information that I provided in API call. Nice. So of course I can execute a second command now. Let's say I want to, let's say it's in page, right? So I'd say 1 to 3. I will zoom in. And it's paid 50 euros and payment daddy, something. And it's all cool. So something happened. Let's first look at events and ensure that it's been done. So payment recorded, very nice, all cool. We happy. So what happens if I pay 50 more? Let's try again. But let's look at this first. So Eventuous thinks about our friends from the who are dealing with front ends, friends from front end friends. Because I keep seeing that teams separating UI development from backend developers. Someone prefers that, the days and stuff like that. So it's fine. If you're dealing with event source systems, one of the issues you encounter from time to time is the fact that you have to deal with projections, read models, and things like that, which are a little bit behind. So I will show it how it's done and stuff like that in Eventuous. But nevertheless, the read model is something where, with the query model, where you read data that you can, like the place where you store data for querying it, because you can't really easily query event store, right? And because you write an events to store and it gets to the subscription, and subscription projected to another database like MongoDB or whatever, and there is a little bit of time involved. And we can, I will talk about this, what this time is and how to measure it and stuff like that. So Eventuous gives you the ability to actually do what some people call optimistic updates. So it returns the result. You don't have to return it, but it gives you the result it can return to the UI. This is the response from the API call, which is a response of the application service. So what does it have? It has a state. That's why I made this properties of state public, so they actually get serialized. I can hide some properties so they won't serialize. You can tune the serializer because the default one is system text JSON. You can tune it so you get access to internal properties, whatever else. It's up to you. The point is, it returns the state as it can retrieve it from the aggregate state record, right? All the properties it can get hold on. And it also, and so it returns the current state. What you can do with the current state, you can put it in UI, right? You don't need to query it. That's the thing, right? So you just executed an operation and you have a new state in hand. Why do you need to query for it? Because you can just return it. That's what I do. And it also returns you a list of changes. And we know now Flux architecture got gained popularity. A lot of people use React. A lot of people use Vue. React has Redux or MobX, and Vue has Vuex and stuff like that. They all work the same way. It's one-way data flow, very similar to event sourcing, but it's done on the front end. So in Redux, you have reducers, which are actually the when functions in my state object. It's very much the same, right? So you have in Vuex terms, which I'm more familiar with, you have actions and mutations. Actions could be asynchronous, and mutations are synchronous because they just mutate the state of the store. What could you do? You just get this list of changes and pass it through your front-end store, and it will know how to project these things like a normal read model projection on the screen. So you didn't need to query anything because you know this is exactly what has been persisted to the store, right? The transaction has been committed. You don't need to reach out to read model to confirm it. It's already done. So by using these results, you can actually avoid requerying the store because you get information that you need in the shape of and form of a state itself, which you can just give to the UI, and the list of changes that if you give it to the UI, they will be able to project it to the front-end store, and the state will change and the user will see the result on the screen. So it gives you the event type using the same mapped string, right? So you can have an agreement with the front-end people how it's projected, and it has all the information from the event. Nice. So let's do another payment, which is this one, execute. And then we get again a new state, and what this state contains. Oh, it's now fully paid, right? The previous one wasn't. and you get another event. So in this case, because we processed the payment, we recorded it, we get payment recorded with almost the same information, but outstanding amount is now 0. But it also produced another event, so 2 events in one go in one transaction, and this event is fully paid. So we know it's fully paid. You don't need to count these numbers on the front end saying, okay, if the number matches, stuff like that, if this outstanding is 0, I need to mark it as fully paid. On the front end, you can just say, I received fully paid, then it's fully paid, right? Easy. So now, look at a store. So we have 5 events, 4 events here. Fine, all good. Metadata objects. What can we use it for? It's empty, right? So I was previously supplying null, now we're supplying an empty object. Metadata is pretty useful to store some technical information. And I think I talked about it a bit too early, so let me just switch to something else really quickly, and before I start talking about how we can use metadata. So you can see a lot of stuff going on here, and I do the better thing because I'm not doing info on something I'm not interested in. I'm doing debug on that. So let me stop the application and bring the last bits that is kind of basic building block, which is the read model projections. A lot of people struggle with that, and I think I managed to make it relatively easy. It can be easier, but for now, I think it's quite good. Let's have a look. So this part, I use MongoDB. So what Eventuous has on another side is the subscriptions. So EventStore.db natively supports real-time subscriptions. So you can subscribe to a certain stream or the global log of events and project these events to another database so you have a queryable model. Because I use Mongo, I use documents, and it has the basic class, which has only one property, with an ID. And you can see it here. It passes an ID. The ID is always string. I think it's everything serialized and deserializes with string, so it's good. I need water. So how this can be populated. So we have this booking document, which is almost representative of state, which is, in my opinion, half anti-pattern, but let's ignore it for now. I just want to show how it works. And this is the projection. Again, there is a building block called Mongo projection. I don't think, or I haven't got to the point where it needs to be done for other databases. Maybe for Firestore, we'll do something. It just does almost everything for you. So it deals with the database and stuff like that. It receives events, and for every event that you have, for every event that you receive in a subscription, it will call this getUpdate function, which can return the update operation. Update operation has the ability to provide a filter and update itself. There is an overload for it when instead of providing a filter, you provide an ID, because usually you update by ID. So it makes working with Mongo projections particularly pretty easy, because you just say, okay, I use Mongo API, set an insert ID, blah, 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 everything's fine. So how it's called, you need a subscription for that. This is just an event handler. Mongo projection is a handler. It's not subscribing anywhere. So it needs to be called by someone. That's where I have subscriptions. And subscriptions, previously you needed to inherit from the base class and kind of customize it. Now it's all gone. So if I look here, I need Mongo, of course. I need a checkpoint store where you put the last offset that you processed, because it needs to start not from the beginning of time, next time the application starts, but from where you stopped, right? So if you process 100 events, you want to start with 101. That's why I need a checkpoint store. I will show how it looks. And you get a subscription. And a subscription does a lot of crazy things for you, because and they are not as easy to implement out of the box, but it's basically all done, right? it uses the builder pattern that's gaining popularity in .NET Framework. That's why I actually introduced it, because it was more fluent API before, like HTTP client registration, but now it's more builder oriented. So you can, all the things that you provide, like add event handler, register booking state projection, which has dependencies. In this case, it has dependency among the database. It will resolve it through the DI container. So you don't need to care about putting dependencies. You need to register them. Yes, I know, magic, whatever, but we know the DI containers really well, so it kind of works. And I don't want to deal with that. That looks really nice, to me at least. You can also tell the builder to configure options. You see it as all stream options. So you can say options dot. You can say whatever, filters, credentials, which serializer to use, blah, 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 blah. Throw an error or not, resolve link to us and stuff like that. So the options provide good defaults, so you don't really often need to configure them, but if you do, it's there for you. And you can see that's very close to the normal libraries provided by Microsoft in terms of how they get registered, how they get configured. So it's not, and it also resolves options. If you just use the normal options, configuration, binding, and stuff like that, it will work. It will resolve options if it's there. If it's not, we'll create a new instance. So let's run it. See what will happen. See, so in here, we got a checkpoint store engaged. So it says, I'm trying to find a checkpoint, nothing is found because the database is empty, and it started a subscription, and it goes and it says, got an event room booked, payment recorded, fully paid, and move the checkpoints forwards. You see there's crazy numbers because the I subscribe to all stream and event store DB checkpoints. There are commit positions, which are in bytes. So they're not easy to monitor, because if you subscribe to normal stream, it will be 1, 2, 3, 4, 5 incremental integer, but not in this case. It will be fixed in future versions, but for now it's like this. But it works. Result. Where is my beloved Mongo compass? Come on. I lost it again. Compass over here. So let's refresh. Bookings, checkpoints. Here we go. We have a position, right? That's the last position we process. If I start application, stop application, start it again, we'll start from here. Bookings. We have one booking only, and it has the current state. So it's been projected from the past events. So I introduced the projection later, then I started doing my operations on the domain model, but it's because it started from nothing, it projected everything from scratch. I can also go here and say, I want to create a new booking with booking ID 234, and everything else will be the same. Let's just put some other number just to see the difference. Boom, done. Here we go, booking fine. So let's go and see what happens in the refresh. Here we go, 3.5, everything's fine. So, cool, everything works. There are a bunch of subscriptions, like subscription to all, stream subscription to stream, persistent subscription to stream, and with the new feature coming, subscription, persistent subscription to all, which allows you to parallelize things. There is a subscription and producer. There is also events to producer for messaging scenarios, for integrations and stuff, which just produces events to the stream without engaged with any domain model, but uses the same building blocks. And you can have producer on one side, subscription on another. So you don't have to use aggregate store for that. And there are the same principles applied for Google PubSub and for RabbitMQ. You create a subscription and a producer, you publish events and consume it on the other side. It doesn't hide transport from you. So if you look at a Google PubSub, for example, it has all the options that you can configure on the PubSub client natively provided for you. It's basically all the same objects. There is no abstraction over that. The only abstraction is subscription itself, like how it's created. To use the API, you can either pre-create it using your DevOps tool, so you can allow Eventuous to create it, but it's all. The same goes for RabbitMQ. It's not in service bus, it's not mass transit, where a lot of things hidden under the hood. It's very kind of open in this sense, so I'm not moving away from the transport. It's all kind of given to you, as it should be. And one last thing is, maybe it's the most important thing that's very new, its integration with Diagnostics and OpenTelemetry. Eventuous, in recent, like a week or two, or actually week, has been instrumented with activity source, which is the Anometrics from System Diagnostics version 6, which it's not released yet, it's beta, but it works. And Open Tracing added to that, but it works like out of the box. Here we go. I added some ASP.NET Core instrumentation with the standard and OpenTelemetry, and I added monitoring metrics for subscriptions, and I added Prometheus exporter, so we can look at them. I won't run Prometheus, it's impossible on my machine. And I did the same for traces, and I added Eventuous tracing. What is traced in Eventuous? Application service, checkpoint store, I think, aggregate store or event store, and subscriptions. So how does it look? And if you're not familiar with Open Tracing, or OpenTelemetry and traces in general, just bear with me, and I hope you will like it. So let's create another booking. Oh no, it was already there. Let's have the even bigger number, 300 euros. The stakes increase. 7, execute. So everything is good. Stream is there. Look at this. This is the event, right? Now we see the metadata coming in. That's why I was mentioning it before, but I was too early. The metadata allows us to put some technical information. In this case, I provided with a distributed trace context. When I provided with a distributed trace context, the subscription can pick it up and say, okay, I project something from the events, right? It knows where it came from. Otherwise, it wouldn't. As a result, if I go to Zipkin, which is the tracing to a very simple one, it's not even like Jaeger, because Jaeger also has a service map and stuff like that. But you can look at this. So what happens? I call the API. It's bloody slow. I don't know why it takes half a second. Maybe I can execute it again and see if it's getting any faster. Zipkin, find a trace, because it might take time to resolve things. Oh, here we go. It became faster. So that's normal time of the operation. What is this? This is a flame graph, right, of my API call. This is my HTTP call. This is provided by this guy, ASP.NET Core instrumentation, which is out of the box in OpenTelemetry. This is mine. This is the application service. You can see the library name is application service. I probably can add more tags, and maybe I will do it, but nevertheless, it's already there in this primitive shape. Here is operation of the event store, which took a little bit less time. So it's almost identical, a couple of milliseconds more, serialization, digitization, stuff like that. This is gRPC client instrumentation provided by OpenTelemetry as well, but for some reason it lost. Oh yeah, it talks to the remote host, which is the event store, right? And the event store address has localhost 2113. So that's correct. So here we have all the information about that. In this event one, we know that this is the stream name and stuff like that. Here, transaction completed, actually. And now we left that process, that thread where this was executed, and we started to do something else in another place. And it could be different service even. It doesn't have to be the same process. This is consuming my event in a subscription. And the subscription is doing this thing with channel, so it pushes things to the channel and it finishes actually. So that's why you don't see the subscription flame going beyond the projection time. It's very fast, it just puts it to the channel. But then this one, I believe, is from the projection. And this one calls the oh yeah, there are two consumers. This is the consumer that puts it to the channel. This is the default consumer that executes all the event handlers. So that's why these things look identical. I probably need to put a type on so you can see which consumer consumed it. And this is actually the Mongo operation. So you can see all the information about Mongo thanks to Jimmy Bogart, who provided the instrumentation library for it. This is insanely powerful because you can see that it's very naive and stuff like that, but things like Datadog and X-Ray and AWS and even Jaeger can give you the maps, service maps. You can see how services talk to each other and stuff like that. Instrument more, and you will see a lot of things. And we are getting out of time. The last thing I want to show is basically co-host 5,000 metrics. Subscriptions are instrumented with metrics, and I know why it's not there. It has to be over here. Prometheus subscribing endpoint. It doesn't start HTTP server, or doesn't map the endpoint. So right now, what I have to do, and it won't really be very successful, I guess. I need to stop this and kill the checkpoints collection. So it reprojects from scratch. Let me run it again. Let's see what happens. See everything reprojected. But now we should see metrics exposed. And I only have one metric for subscription now, but that's the most important one. That's the subscription gap. Subscription gap measures the distance between the last process event and the end of the stream. Right now it's negative, and mainly it's because of this bloody commit position that is counting in bytes. For normal streams, it would be the normal operation. It should be not 0, actually. But now it's moved forward because you don't process some system events and stuff like that, so that's fine. If it starts to grow, and it keeps growing continuously, you need to monitor this metric. You will need to see what's going on, because the delay of your query models will return stale data. And that's one of the most important metrics to consume and visualize and alert in event source systems. And that's provided out of the box now. So it has subscription ID. You can have one graph in Grafana with multiple subscriptions, and everyone shows a different place and stuff like that, or a different graph. I will introduce the time for that as well, so you know how much time it takes to project. And this is just a start. So plans are, these bits and pieces were committed just a few minutes before I started to talk. So I'm really glad that everything works as expected. Eventuous.dev, have a look. It's open source, completely free for now. I'm kidding. We have some community. There is a Slack link somewhere. I tweeted about it. I can put it wherever you want. I don't have it with me. But if you come over here and go to the issues, maybe the Slack link is there. It's getting traction is having 1, 2, 3. It's nice. I haven't made it up. It's has this number of stars. It has this number of downloads. You know, for the project that started 5 months ago on the cover and has never been kind of promoted before, I think it's pretty decent. So we're getting there, and documentation will be updated to include all the bits and pieces, and I continue improving instrumentation. So if you want to help, come over. There are a bunch of issues here to pick up. We can have a design discussion, stuff like that. We can plug in Kafka, whatever. I mean, a lot of things to do, but it could be awesome, really. I mean, and there are big plans. So I hope that this talk, if you're a .NET developer, it can help start you out with building the event source system. And on that optimistic note, I'm 3 minutes over time. I really apologize. Thank you, and getting back to the stage.
Thank you, Alexey. And we have a question for you too. Frameworks or libraries such as React and Angular lowers the threshold into web development. Do you think that Eventuous lowers the threshold for developers to start using event sourcing?
Yeah, that's actually the motivation to kill to lower the barrier, because in Event Store we provide a product for that and say, okay, this is the database. But unlike many other databases where you can, like in Mongo, you can just say, okay, I take my object, I serialize it to Bison, and I shovel it to the database, and it's done, right? Until you encounter issues with this database size, you kind of find. In SQL, it's a bit more. You need to learn something. You need to build tools. And then people say, like, using relational databases for persistence is easy. And then if it's easy, why do we have entity framework core, which is like hundreds of thousands of lines of code, right? So luckily, Eventuous is not that big, but it also has more than just the persistence. It provides with some messaging patterns, the application layer, decent instrumentation now, which is 7 days old or even less. So I think, yes, that was the motivation. It's just, okay, you drop the library and you start providing value from day one. And it's very fast. You can, like the Bootstrap, it's very small. And I'm planning to create a template, like, just drop a template and .NET template and start coding. So yes, that's the idea.
Yes, thank you for that answer, and thank you for your talk. And now we're going to take 5 minutes break before our last talk of the day.
Thanks.